So today we're going to talk about factors. Yesterday we talked about multiples. Factors is another term that you need to be very familiar with. So a factor is a whole number that will divide exactly into another number. For example, if we start with the number 12 and we divide that 12 by 1, the factor we get is 12. The answer we get is 12. 12 we can also divide by 2 and the answer would be 6. 12 we can also divide by 3. The answer would be 4. Is there anything else we can divide by 12? 12 divide by? Yes, we can divide it by 6 and get the answer 2. Which one have I forgotten? 12 divided by 4 is 3. So this proves when we start with the number 12 we can factorise it. So to factorise it we often talk about a factor tree. So if you start with the number 12, the factors of 12 are these numbers. So 12, 6, 4, 2, 3 and of course 1. I didn't do that one. 12 divided by 12 is 1. So these are the factors of 12. Let's look at the factors of 18. So you can always divide a number by itself and get the answer 1. 18 is an even number, so you will always be able to divide an even number by 2, so the answer will be 9. 18 we can also divide by 9 and get the answer 2. Is there anything else that divides into 18? We can divide 3 into 18 and get the answer 6. And we can reverse that, divide 6 by 18 and get the answer 3. So similarly, we can start with the number 18 and the factors of 18 are 1, 9, 2, 6 and 3. So these are the factors. This is a way to demonstrate how to do factors. And sometimes you are asked, like yesterday we talked about the lowest common multiple, sometimes they ask you for the highest common factor, the HCF, the highest common factor. So that would be the largest number which is common. So it would be the highest common factor of 12 and 18. So you need to look at all the answers. Which one is the highest? Well, we both have 1, but it's not the highest. Both have 2, but it's not the highest. This one has 3, but it's not the highest. This one doesn't have 4. It has 6, and this has 6. The other factors are 9 and 12. So the highest common factor of 12 and 18 would be 6. So whenever you are factorising, you are finding all the answers. When you divide anything that can be divided, any whole number, you get all the answers. If you set it out like this, you can then use it as a guide to check which ones are the same, and the highest common factor is the answer which is the highest in both your answers for factorisation. Okay. When I've written down here, have a look at the challenge, the mastery challenge today, because as I said yesterday, this should be revision. This should be for you to remember what factors are all about. There's a lovely challenge, and the challenge involves prime numbers. So tomorrow's work is going to be talking about prime factorisation. This is a method of finding all the prime numbers. I would suggest at home that you print off 100 square if you can and follow this method so you've got all the prime numbers to 100. Just for demonstration purposes, I'm only going to go up to 50 today. Alright, so 1 is a strange number because although you think it's going to be a prime number, because it's an exception, because every prime number can only be divided by 1 in itself, but 1 is an exception because it can only be divided by 1. So 1 is not a prime number. The first prime number is 2, because 2 can only be divided by 1 and itself. So I'm just going to make a note of 2, the first prime number. So if you get the number 2 and you cross off all its multiples, all the multiples of 2 are in the 2 times table. So I'm just going to cross off all the even numbers, because any even number will always be a multiple of 2. you cross off all the even numbers in the whole 100 square. None of those can possibly be prime numbers because they will be multiples of other numbers as well as themselves. 1 and 2. There will be more. Okay, so the following prime, next prime number is 3. So we need to cross off all the multiples of 3. So we've got 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36, 39, and if you're stuck and you get lost in your times table, you can just count 1, 2, 3, 42, 1, 2, 3, 45, 1, 2, 45, 1, 2, 3, and it's already crossed off, and so on. So the next, so 3 is your second prime number. The next one is 5, because 5 can only be divided by 1 in itself. Now, any number that is a multiple of 5 will end in 5 or 0. So we've crossed all those off. They cannot be a prime number because they are multiples of more than 1 and themselves. The next prime number is 7. So we've got 1, 3, 5, 7. We need to cross off all the multiples of 7. So we have 7, 14, 21, 28, we've already crossed a lot of these off, 35 we've crossed off, 42 we've crossed off, 1, 2, 3, 4, 5, 6, 7, 49 we need to cross off. The next prime number would be 11. Now all the multiples of 11 would be the numbers that double numbers, so you've got 11, 22, 33, 44 all crossed off, and so on. Can you see what's happening? We're sieving out all the numbers that are not prime numbers and leaving behind all the prime numbers. So the next prime number would be 13, and you would continue the process where you cross off all the numbers that are multiples of 13. And if you're not sure of working out the multiples, just count on 13. So 13 plus 13 would be 26, and so on. And you continue to cross off all the numbers that are multiples, and eventually you will be left with all the prime numbers in the 100 square. So you'll have all the prime numbers up to 100. You'll have highlighted all of those, and if you keep that, it's a great reference for you to use in tomorrow's factorisation lesson. So if you're doing the mastery on Tuesday, this is great because you'll need it, and you can keep it as a reference for Wednesday's prime factorisation lesson. If you can't print something off at home, there's a link that I've put on the PowerPoint that we're sending home, where there's a splat 100 square, and you can simply turn over the multiples and cross off the others, or leave the others blank when you turn over, or sorry, blank off the ones that you would have crossed off, and it will leave exposed the prime numbers. So that's a method of working out all the prime numbers, and obviously you can keep going past 100 forever and ever and ever, but if you've got this reference, it will help you with prime factorisation in tomorrow's lesson. Thanks very much for listening, and enjoy your maths today.